All right, everyone. Let's have a look at some questions from this paper now. March 2020, paper 1, variant 2. Okay, March 2020, paper 1, variant 2. Again, a reminder to submit that poll if you haven't already. Let's have a look at some questions from this paper now. The ones that you guys found difficult. Okay. First one, increasing or decreasing function. You have to find the derivative and then show that it's increasing or decreasing. Okay, I hope you are done with that, because nobody has voted for this. Transformations, this is a simple one. This number 3, rotated about y-axis. You just have to make x squared the subject and put the limits from 1 to 5 after integrating. Okay, question number 4. Okay, so let's start with this one. Question number 4 from this paper. That's what a relatively higher number of you have asked about. Let's start with this. Question number 4 from this paper. It says the curve has equation y equals x squared minus 2x minus 3. A point is moving along the curve in such a way that at P, the y coordinate is increasing at 4 units per second and the x coordinate is increasing at 6 units per second. Find the x coordinate of P. Okay, so what information are we given here? We are given that the function is y equals x squared minus 2x minus 3 and dy over dt, that is equal to 4, dx over dt, that is equal to 6. Both of them are increasing, so the rate of change is going to be positive for both of them, right? This is the rate of change for for y and x, right? dy over dt and dx over dt. And now we need to find the x coordinate of this point where both of these things are true. Now, using dy over dt and dx over dt, what we can do is we can figure out what dy over dx is going to be at this point. How can we do that? Using chain rule. So at this particular point, where both of these things are true, when dx over dt is 4 and when dy over dt is 4 and dx over dt is 6, at this particular point, how do you find dy over dx? You would use chain rule for that. Numerator of the first fraction will be dy, denominator of the second fraction will be dx, and in the middle, you've got the third term, that's dt. Now, what's dy over dt? dy over dt is 4. dt over dx, that's reciprocal of this, that will be 1 over 6. So dy over dx therefore turns out to be 2 over 3. So the x coordinate of P, the point P that we're looking for, at that particular point, dy over dx is supposed to be equal to 2 over 3. So all you have to do is find the derivative of this function. Let's see what that turns out to be. dy over dx, that will be 2x minus 2. The derivative has to equal 2 over 3. So we get an equation like this. 2 over 3 equals 2x minus 2. And that gives us 2x equal to 7 over 2x. 7 over, no, sorry. Let's put this on my calculator. So we don't do a careless error. 2 plus 2 over 3, that will be 8 over 3. 2x equals 8 over 3. And the value of x turns out to be 8 over 6, which is 4 over 3. This is the x coordinate of the point P where both of those conditions are true, where dx over dt equals 6 and dy over dt equals 4. That's what we were looking for. Make sense? That's the first part. In fact, that's the only part of this question. Question number 4, pretty straightforward. That's what they asked. That's what you asked about. Okay. Now the next one after this is question number 8. Let's try that. Yeah, I hope you're done with the rest of them that you have not voted for. Let's do question number 8 then. It says a woman's basic salary for her first year with a particular company is $30,000. And at the end of the year, she also gets a bonus of $600. For her first year, express her bonus as a percentage of her basic salary. Okay, what's the percentage of bonus as of the basic salary? You'll say 600 divided by 30,000 multiplied by 100%. What do you get from this? 600 divided by 300, that's 2%. So the bonus turns out to be 2%. That's the first part. That's what we were looking for here. Now it says at the end of each complete year, the woman's basic salary will increase by 3% and her bonus will increase by $100. Okay, now that's interesting. At the end of each year, the basic salary is going to increase by 3% and the bonus is going to increase by $100. Express the bonus she will be paid at the end of her 24th year as a percentage of the basic salary paid during that year. Okay, now this looks a bit tricky now. Let's think about this. So we've got two numbers that we are starting from. We've got basic salary. In the first year, let's write it like this. This is the first year. In the first year, the basic salary is 30,000. And then in the second year, what is that going to be? It's increasing by 3%. So basically, from 100%, you're going to 103%. What's the ratio? The ratio is going to be 1.03. Remember, percentage increase or decrease, that means it's a geometric progression. And the ratio of that progression, if it's going from 100% to 103%, that means the ratio is going to be 1.03. That's the ratio. Now, you can figure out the second term here, keeping in mind that it's going to be a GP now. If you want, you can figure out the second term, 30,000. Increase that by 3%. You would get 30,900 as the result for this. And if you find this number, you can also find the ratio by just dividing these two numbers then, and the ratio will turn out to be 1.03. So the basic salary is a geometric progression with the first term being 30,000 and the ratio being equal to 1.03. That's the basic salary. And then what about the bonus? The bonus in the first year is $600. And the bonus in the second year, it increases by $100. So it becomes $700. It's increasing by a certain amount. It's increasing by a fixed amount, by a fixed number. That's an arithmetic progression because in this case, the difference is going to remain constant. So the bonus is an arithmetic progression with the first term equal to 600 and ratio equal to, difference equal to 700 minus 600, which is 100. That will be the difference. So for the GP, we have the first term and the ratio. For the AP, we have the first term and the difference. And now they say, express the bonus she will be paid at the end of her 24th year as a percentage of the basic salary paid during that year. Can we find the 24th term of the GP and the AP now? Let's do that. Let's find the 24th term for both of them. Remember the formulas for both of them? Formula for a GP is AR raised to the power n minus 1. So if you're looking for T24, what would that be? A, which is 30,000, multiplied by 1.03 raised to the power n minus 1. That means 24 minus 1. That's 23. That is going to give you the salary in that at the end of the 24th year. Let's see what that turns out. 30,000 into 1.03 raised to the power 23. That is giving me 59,207.595. That's what the basic salary becomes after 24 years. What about the bonus? Bonus is an arithmetic progression. That's a plus n minus 1 times d. So this will be 600 plus n minus 1. That means 24 minus 1 times the difference, which is 100. Let's see what this turns out to be. 600 plus 2300. That is 2900. That's the bonus. What's the percentage now? Percentage of bonus as compared to the basic salary. That's going to be 2900 divided by 59207.595 multiplied by 100% and see what that gives you. 59207.595. That is giving me 4.898, and that will round off to 4.90 basically. 4.90%. That's the percentage of the bonus after the end of the 24th year, at the end of the 24th year. That's what we get. Make sense? Any problem with this? No? Okay, makes sense. Let's move on to the next one now. That was question number 8. Now, no one has asked about question number 9. There are a couple of votes for 11 only. Let's skip that for now as well. Now, this is the one that has the most number of votes. Question number 12. Okay, not 11, 12. This part C actually looks interesting. Make sure that you've tried this. Okay, so this is the next one that you're asking about. Question number 12 from this paper. Let's try this. It says the diameter of a circle C1 has endpoints at -3, -5, and 7, 3. Find an equation of the circle C1. Okay, so the diameter has these endpoints. Can we find the center of the circle? Center will just be the midpoint of the diameter. That will be -3 plus 7 divided by 2 and -5 plus 3 divided by 2. What does that give us? 2 and -1. Okay, these are the coordinates of the center. What about the radius of the circle? You can find the distance of the center from any one of these 2 points, and that will give you the radius. Let's use the second point, 7 minus 2, x2 minus x1 whole squared, plus y2 minus y1 whole squared, 3 minus -1, that becomes 3 plus 1 whole squared, and the radius turns out to be 5 squared plus 4 squared. That's 65 over 4. Square root of this. That's the radius. What about the equation of the circle now? X minus a whole squared. So this is the center. This is the radius. Equation of the circle is going to look like this. X minus a. This is a. This is b. X minus 2 whole squared plus y minus -1. That becomes y plus 1 whole squared equals square of the radius. That becomes 65 over 4. And that's the equation of the circle that we were looking for in the first part. No? Okay, I'm sorry. Let me correct that. 5 squared plus, I'm not sure if I put something else in my calculator. I'm sorry, this is 41. Yeah, under root 41. And this actually becomes 41. Thank you. What did I input there? I'm not sure. I did something else, which was giving me something in decimals. Yeah, so that's square root of 41. The radius turns out to be square root of 41. So the equation has 41 on the right side. That's the equation. Yeah. Okay, let's look at the second part now. The circle C1 is translated by 8,4 to give circle C2 as shown in the diagram. Find an equation of the circle C2. Okay, so how do we think about this now? We can think of it either through transformations, that we've got this function, this equation, apply this transformation on that. That's one idea, but it's going to be easier to think of it like this, that since the circle is translated, the radius of the circle is going to remain the same as before, right? Because translation does not change the shape of the figure or the size of the figure. Radius will remain the same. The only thing that changes is the center. We know the center of the first circle, C1, that is 2 and minus 1. So that's maybe somewhere around here. This is 2 and minus 1. Okay. Now, when you do this translation on that, that means 8 units to the right. 2 goes to 10. 2 plus 8, that becomes 10. So the center becomes 10. 4 units up, minus 1 plus 4. What does that become? 3. So the coordinates of the center of the other circle are there for 10 and 3. Now, once you have the center of the other circle, you can write down the equation of that other circle as well. You would say that's x minus 10 whole squared plus y minus 3 whole squared equals r squared. That's the same as before. That's 41. And that will be the equation of the second circle. Okay. So the x coordinate of the center, you add 8 to that. To the y coordinate of the center, you add 4. You get the center of the other circle. Once you have that, you can write down the equation like this. And that's your final result. Okay, that's part B. Now let's look at the next one. Now it says the two circles intersect at points R and S. Show that the equation of the line RS equals this. Okay, so we are given that the points of intersection of the two circles are R and S. Okay, we can see them here. R and S. We need to find the equation of the line RS. Okay, now how do we think about this? Equation of the line RS. Now, one way to think about this could be that you solve the equation of the first circle and the equation of the other circle simultaneously. You will get points of intersection. From that, you will get point R and you will get point S. And then you find the gradient of RS and then write down the equation. That could be one possibility. But in this case, you could actually do something quicker. And that's this. You can basically join the centers of the two circles. Let me show you what I mean by that. These are the centers of the two circles. If you were to join both of them, like this, RS is actually going to be perpendicular to this. RS is going to be perpendicular to this, and it is going to pass through the midpoint of these two centers. So RS is basically perpendicular bisector of the line joining the two centers. So all you have to do is find the perpendicular bisector of these 2 points. And that's it. And that will give you the result. Make sense? Now, let me see if I can show you the proof for that somehow. It's kind of obvious, but let me see if I can show you some mathematical logic for that. Think of this. If this radius is something, and this radius is something, they're both equal to each other. If they're both equal to each other, this is the midpoint of that chord. And yeah, you can actually do it. Yeah, do it like this. RS is basically a chord in both the circles. RS is a chord of C1 and also of C2, right? If I were to draw a line that is perpendicular from C1 to the midpoint of this chord, the angle made here would be 90 degrees. RS is also the chord of the also a chord of the other circle. So I can also draw a line from the other center to this point, and that will also meet this at the midpoint. So this point where both the centers are meeting with this chord, they are the midpoint. Since they're meeting at the midpoint, the angle is going to be 90 degrees. This complete angle is 180. That's why it's a straight line, and RS becomes perpendicular bisector of that. All right. So basically, all you have to do then is find the equation of the perpendicular bisector of RS, and you would get that equation that you're looking for. Let me do that now. We've got 2 points, 2 minus 1. That's the center of one circle. And the center of the other circle was 10 and 3. We have to find the midpoint. What's the midpoint? Let's call that M. That will be 2 plus 10 divided by 2. And that becomes minus 1 plus 3 over 2. And that gives you 6 and 1. And then you find the gradient of these two circles. Of the centers of these two circles, let's actually call these something. Let's call this center X, let's call this center Y. And this point where they're meeting each other, let's call this M. Gradient of XY, what's that? That will be 3 minus 1, that's 3 plus 1 divided by 10 minus 2. This gradient turns out to be 4 over 8, which is 1 over 2. Then what about the gradient of the perpendicular of this line, which is RS? Gradient of RS therefore becomes minus 2, negative reciprocal of this. And using this now, you can write down the equation. You've got the point, you've got one point that lies on that line and the gradient of that line. What's the equation going to be? Y minus y1, that's y minus 1 equals m, which is minus 2 into x minus 6. Now you have to rearrange this, and that gives you y equals minus 2x plus 12 plus 1, and y equals minus 2x plus 13. That's the equation of that line RS that we were looking for. Okay, that's part C of this. This is the quickest way of doing this. The other possibility could be if it does not come to your mind at that point, you can just solve the equations of both the circles simultaneously, find the points R and S, and then find the gradient of RS and write down the equation using that. That could be another possibility. And that will also work. All right, now it says, hence show that x coordinates of R and S satisfy this equation. Okay, now do we have the points R and S? No. So we need to show that the x coordinates of R and S satisfy this equation. Now, R and S are the points of intersection of the two circles. But at the same time, R and S are also points of intersection of this line and any one of the two circles now. So basically, since you have the equation of the line RS now, you can say equation of the line RS is y equals minus 2x plus 13. And then along with that, you take the equation of any one of the two circles, any one of them, it doesn't matter. If you were to solve them simultaneously, that is also going to give you the coordinates of the points R and S. Let's take this first circle, which was x minus 2 whole squared plus y plus 1 whole squared equals 41. Write that here, x minus 2 whole squared plus y plus 1 whole squared equals 41. You could take the other circle as well. It won't matter. You'll get the same equation from that as well. And now you solve these two simultaneously because R and S are also supposed to be points of intersection of these two graphs, these two functions. Let's put this on the other equation. You say, let's input y equal to minus 2x plus 13 here. What do you get from that? X minus 2 whole squared plus minus 2x plus 13 plus 1 whole squared equals 41. Let's simplify this a little. X minus 2 whole squared plus minus 2x plus 14 whole squared equals 41. Now expand it. X squared minus 4x plus 4 plus 2x whole squared. What does that become? That's 4x squared plus 2 into minus 2x into 14. That will be 4 into 14, which is 56. X plus 14 squared. I think that's 196. Just confirm that. 196 minus 41 equals 0. And that simplifies to 5x squared minus 60x. 200 minus 41, that's 159 plus 159 equals 0. And that's what you have to show, that if you were to solve this equation, you would get the points points R and S from that. You don't have to find those points. You just have to show that R and S are going to be solutions of this equation. They satisfy the x coordinates satisfy this equation. And that's what you have to prove. You just stop it like this. Make sense? And that's your final answer for D. And that's it for this paper. These were all the questions that you asked about. We could do one more quickly if you want. You can let me know if there's another question. Those of you who are in the meeting right now, let me know if there's one other question that you want to do. Write that in the chat box so I can decide which one has the most number of votes in the chat box. Those of you in the live class right now, let me know which other question you would want me to do from this paper. One more question. Okay, so I'm getting all different suggestions. Can you specify which particular parts of these questions as well? Okay, so let's have a look at some parts now, some specific parts now, very quickly. This one is not that difficult. You should be able to do it. Just start it. It may be looking difficult to you just by looking at it. How do you find the area of the shaded region? Let me just explain this to you, how you can actually find it. So first of all, think logically, okay, what area needs to be subtracted from what area? So in this case, you can think of it like this, that what information are we given? AOB is given. This is a sector. Okay, so this is one sector, OAB, right? And we have another sector inside it with the same angle, and that's it. That's this sector. And we have this perpendicular. Okay, so how do we find this shaded region? So you have to find the areas of these figures. Find the area of this sector. So that's the complete diagram. Okay. So we'll find this area of the sector AOB. You'll start with that. Now from this whole sector, you need to subtract two things. You need to subtract this part and this part. Those are the two things that you need to subtract from this. Now subtracting this smaller sector is easier. Let's start with that. You say, let's subtract from this sector DOC. Okay, this much you can do. All right, from the bigger sector, we subtract the smaller sector. And now the problem is we also need to subtract this blue part now. What about that? How do you subtract that part? For this, you will need to do something like this. You'll say, how do you find this area now, this blue area? For finding this blue area, what you can do is you can say, let's find the area of this whole sector, right? From the area of that whole sector, that sector AOB, subtract the area of this triangle, this right angle triangle. That's triangle ACO. And that will give you that shaded region. Okay. Now, in fact, it's much quicker to do it something like this. I think this is a bit too complicated because eventually you get this thing. When things get subtracted, you actually end up getting something like this. So triangle ACO minus the sector COD. In fact, actually finding that area is actually going to be relatively straightforward. The main problem is going to be finding any unknown lengths. How can you do that? Area of triangle for this, you need one side and maybe another angle. We've got this angle already. If we can find this length somehow, we can find this area. But the problem is, how do you find this length? I think it's going to be easier just to do this quickly then, rather than trying to explain it. Let's actually do it. Let's actually do this first. Angle AOB equals 0.8 radians. Point C on AB is such that, on OB is such that it's perpendicular to that arc. CD is part of a circle with center O, where D lies in O. You find the area of the shaded region. Okay. How do you find the area of the shaded region? Now, let me start like this. Let's find the area of the triangle ACO. Subtract from that the area of the sector DOC. Now, how can we find these two areas? That's what the question is. Okay. How can you find these two areas? Let's think of the sector DOC. What do you need for that? You need the radius and the angle. You've got the angle, but you don't have the radius. Instead of radius, you know that this whole length of the bigger sector is 6 centimeters. If this length is 6 centimeters, this is also 6 centimeters. OA is also 6 centimeters. And if OA is 6 centimeters, what you can do is you can find OC using trigonometry. Okay. So how do you do that? It's a right angle triangle. It will be base and hypotenuse. We'll say OC over 6, that equals cos of 0.8. And that's going to give you the length OC. Let's see what that turns out to be. Make sure your calculator is in radian mode. 6 cos of 0.8. And that's giving me 4.18024. That's the length OC. So now you've got everything that you need. So now it's pretty straightforward. You'll say triangle area, that's half into AB sine C, half into 6, that's one side, into 4.18024, that's another side, into sine of the angle, that's 0.8. Subtract from that 1/2 into area of this sector, that's half r squared theta, that's 4.18024 whole squared into angle, which is 0.8. And that will give you the result. That's 6 marks. So the only thing that you had to figure out here was this angle. Once you have that angle, the rest is pretty straightforward. Does that make sense?
Yes, sir. When do we use 1/AB sine, and when do we use just like 1/AB?
You can 1 base into height. That's when you have one side and a perpendicular to that. The other side should be perpendicular. This formula that we're using here, this can be used when you have a triangle in which no side is perpendicular, and you have an angle like this, two sides are given and the angle between them is given. There's no right angle, then you use this. So generally, when you have a right angle triangle, you have one side that you have the sides that are perpendicular. So if this was a right angle triangle that we were looking at, if in this triangle we knew the length AC and OC, we could just use half into base into height for that. But since in this case, the sides that we know do not make a 90 degrees, which are these two sides, we can't use half into base into height here. We use these sides along with the sine of the angle between them. Okay.
Okay.
In the other case, even if you were using these sides, you could still use half into AB sine theta here. But in this case, what happens is half into AC into OC into sine of the angle between them, that's 90. Since sine of 90 is 1, it does not make any difference if you put sine there or not. Okay, so this is actually a more general formula. Okay, when angle is 90, sine 90 becomes 1, so this thing gets eliminated, and you're just left with this part, and that's where you get this from, half into base sine half into base into height. Okay, anyway, let's get back to let's move on to the next page, next question quickly. We can do one more part, and then we end. What was the other one that you were asking about? We've done this multiple times before, by the way. You need to remember that condition for composite functions to be formed. The range of the inner function, the whole range of the inner function, has to be part of the domain of the outer function. You have to use that. But for this, we will need to do the previous parts as well. So I will not be able to do the whole question right now. But it's the same idea that we've discussed, I think, at least a couple of times before. In order for a composite function to be defined, the range of the inner function, the whole of that, whole of the range of the inner function, it should be part of the domain of the outer function. That is when the composite function can be formed. Right? We've done multiple questions like this before. So I'm going to skip that for now. Okay, let me do this quickly for you. Last part of this question, right? 11C. What about the first two parts? Let me see if I can find the marking screen for this somewhere. So be quick about it. Parts A and part B. Can you tell me the answers for them? First one is just a quadratic equation. What do you get from the first one? Okay, so from the first one, you would get something like this: tan x equals 2 and tan x equals minus 1/3, and that is going to give you x equals 63.4 degrees. And also x equals 161.6 degrees. Okay, these are the two answers that you get from this. From the first part, find the set of values of k for which this equation plus k minus 2 plus tan x minus 2 has no solutions. Okay, when will you get no solutions for this? It's a quadratic equation, right? How do you get no solutions for something? B square minus 4ac equals 0, right? So that will be minus 5 whole squared minus 4 into 3 into c, that's k, that equals 0. Sorry, less than 0. And you can solve this and see what that turns out to be. 25 minus 12k, that's less than 0, k will be greater than 25/12. That's the second part. Okay. And now you're asking about the third part. It says, for the equation 3 tan square x minus 5 tan x plus k equals 0, state the value of k for which there are 3 solutions in this interval and find these solutions. Okay. You want 3 solutions from 0 to 180. Now, generally, you know what happens when you get any values of tan x between 0 to 180, we generally get just one solution. So if tan x was equal to, let's say, 0.5, tan is positive. Where is tan positive? Tan is positive in the first quadrant. In the second, it's negative. So out of these two quadrants, it's only positive in the first one. You get just one answer. You would just get one answer here. If tan was negative, you would just get one answer in the second quadrant. That will be here. So you either get one answer in the first quadrant, or you get one answer in the second quadrant. So when you have a quadratic equation and you solve a quadratic equation, you get two solutions at the end from that quadratic equation. One of them, if it's positive or negative, each of them is going to give you just one answer in this interval from 0 to 180. Except if you end up getting tan x equal to 0 somehow. Because from 0 to 180, tan can actually be 0 at 2 points. Tan can be 0 when x equals 0, and it can also be 0 when x equals 180. So if one of the possible answers from this equation is tan x equal to 0, you would end up getting two answers from that, and then from whatever the other value of x is, either that's positive or negative, you'll get one more solution, and in total you would end up getting three solutions. So three solutions are only possible if one possible value of tan turns out to be equal to 0. That's the only case when you can get three solutions in total from here. So what do we want now? We want one tan x value to be 0. How can that be? How can we get one tan value equal to 0 here? If this k gets eliminated. If there was no k here, we would get 3 tan square x minus 5 tan x equal to 0. We can take tan x common then. And that leaves us with 3 tan x minus 5 equals 0. So when one factor becomes tan x, we get tan x equal to 0. And the other factor is 3 tan x minus 5 equals 0, which gives us tan x equals 5 over 3. Now from this, you would get x equals 0 and also x equals 180. From the other one, you would get one other solution. So for there to be three solutions, the value of k has to be 0. The value of k has to be 0. Two solutions are 0 and 180, and the third one, you can find the basic angle here. We'll say tan alpha equals 5 over 3. See what the basic angle turns out to be. Tan inverse, make sure your calculator is in degrees mode here. Tan inverse of 5 divided by 3, that's giving me 59.04 degrees. Now here tan is negative, tan is positive. Tan is positive in the first quadrant. So this is another possible answer. We're getting x equal to 59.0 degrees. So the three possible values of x that we get here are x equals 0, x equals 180, or 59.0. This is the only value of k that can give you three solutions, because this gives you tan x equal to 0, which gives you multiple solutions at the end within that interval. Is that okay?
Sir,
Yes.
sir, we have also found the value of k in part B. Can't we put it in the equation below?
First of all, we haven't found any one particular value of k. That's one thing. And the second thing is it's not even related. As in, it says find the set of values of k for which this equation has no solutions. That's another case. Here it says for this equation, state the value of k for which there are three solutions. That was the case when there are no solutions. Now this is the case where three solutions. These are two different things. There are two different scenarios that they're
Okay, sir.
Okay. We can't use what they gave in the previous part here because that was a different case that they gave here. Okay. And even then, there's no specific value that we know of for k here. And in fact, if k was greater than this, there would be no solution. We want three solutions. So k can't be greater than 25 over 12. It has to be less than 25 over 12 for there to be any solutions. Okay.
Yes, sir.
All right, good. No problems?
Yes, sir. Question number 5.
Abdullah, I'm running out of time. We have to start the next class as well. We need 10-minute break from Maghrib as well.
Okay, sir.
What exactly is the problem?
Sir, I will send you the solution where I am getting stuck on
Yeah,
WhatsApp.
you can let me know. Yeah, you can let me know where exactly you're stuck, and I'll let you know
Okay,
what
sir.
to do.
Okay, sir. Thank you, sir.
It doesn't look very difficult, by the way. All you have to do is multiply this on the other side. Okay. Once that's done, 2 and 2, they will get cancelled. And then you just have one tan theta term, one sine theta term. Tan, you convert that to sine theta over cos theta. Okay. And then you will get, you'll multiply this and then simplify that further. So it's not that difficult, but send me the working. I'll tell you where you start. Okay.
Okay, sir. Thank you.
Okay. Okay. Allah Hafiz.
Allah Hafiz, sir.